Woohoo! Welcome back. Today we're going to be talking about multiplication with Godzilla. Yay! So, multiplying algebraic expressions basically means we've got to learn to multiply stuff that's got variables in it in addition to the constants or the numbers. And the way that we approach this is according to how many terms or how many pieces there are in the algebraic expression, the little piece of algebra. So we're going to start off with multiplication of monomials. Now, as you might guess, I'm looking for green because, Godzilla loves green. Mono in this case stands for one. And so these are going to be expressions that have one term. You'll notice that this is just a single piece. It doesn't have like x plus y or, t minus x. Each of these chunks inside the parentheses have one term. So that's a monomial. And if you're multiplying monomials, the great thing is that you don't have to worry about distributing anything or anything exotic. You just multiply the parts that match, which is really great. It's a lot like numbers. So if I look here, I've got a -8 and an x cubed and a y squared and a t, and then a -2 and an x and a y cubed and a t. And the only reason that I have to use parentheses at all is because these negatives, if I leave them just sitting out, they could look like we're actually subtracting instead of multiplying. So I want to make sure it's clear. And once I've got everything all written out, and again, this step, completely optional. If you can do this in your head, that's awesome. My head doesn't always work that great, so I'm going to use the paper and my head to kind of help each other out. I've got a -8 and a -2, and I'm going to bring them together. And again, this is an optional step. You could do this in your head. I'm going to write the x's together. So I've got an x cubed and an x. I've got a y squared and a y cubed, and a t and a t. And again, totally optional step. This is just going to help me to not forget anything. And then I know -8 times -2, two minuses, make a plus. So I've got +16. I've got 3 x's, x cubed and another x, and they're all multiplied together. So 3 plus the 1x here, I've got 4 x's all together. 2 y's, y times y, and then 3 y's, y times y times y. So all together, 5 of them, y to the 5th. And then I've just got the 2 t's, so I write that as t squared, and I'm done. Yay! So multiplying two monomials is actually pretty straightforward. Where things get exciting is when we multiply, and I know this sounds so fancy, multiplication of a monomial and a binomial. Well, again, we've got that monomial, which is one term, but then I also have a binomial, which means it's 2 terms. And I should write this in for the folks who aren't watching the video. Oh no, not 1 terms. Oh my goodness. What? I didn't write that. Wait, is that a pterodactyl? Oh my goodness, it's a pterodactyl right behind you. Don't look at the screen. What? I didn't write 1 terms. What are you talking about? Okay, so I've got 1 term and 2 terms. So what does it look like? This looks like a single term, see on the outside, and then I do have parentheses here, but notice I have a minus in the middle. And this means there are 2 terms. So this right here has 2 terms. So the way we do this, I've got 3a squared b times the quantity a squared minus b squared, and this is going to be multiplied out using the distributive property. If I have a single term on the outside and then 2 terms on the inside, either with a minus or a plus in the middle, does not matter, then I'm going to do this thing that you may have seen in the past. Someone may have drawn arrows for you like this. You have to make sure that this term on the outside which actually technically is a factor in this setting, but this little chunk on the outside gets multiplied times each of the ones on the inside. So what does that look like? It looks like 3a squared b times a squared, and then the minus 3a squared b times b squared. So you see there's the a squared there, and there's the b squared there. So each of them gets their own 3a squared b, and then each piece gets multiplied like we did up here, because each piece now is a monomial times a monomial. So I've got a 3 and an a squared and an a squared and a b. And then here I've got a 3a squared b squared. Didn't really have to change any orders. So altogether 3, and then I've got 4a, so it's a to the 4th b. 2 plus 2 is 4. And then over here I've got 3a squared, and then I've got 1b and another 2b's, so I've got 3 of them. And there's my answer. Woohoo. And again, your choice whether to box things or not is dependent on, whatever instructor you've got. If you're taking my class currently, I don't care. You can box them. You don't have to. Some people love it. Some people hate it. I encourage you to box it if things are starting to look a little bit chaotic, if things are looking a little messy or just very complicated, because it does make it easier to find, where are you going, which direction, and where's your final answer. Okay. So these two are the ones that we use to practice to get into dum dum dum. Here we're going to multiply binomials. So again, two terms without the F word. Dum dum dum. And you may or may not have learned the F word in the past. We're not going to use that right now. We're going to talk about the basic technique, bare bones, back to basics, the completely analog way to multiply out. So let's take a look here at what's going on. So in my example, I've got x plus 1, that's two terms, binomial, and x minus 2, which is also two terms. So now it's not as obvious what's going to happen. So this is what I'm going to recommend. Now, are there a million ways to do this? Yes, there are a billion probably ways to do this. One of the big ones that gets taught is the lattice method, or setting up a chart. Some people love the chart method. Some people have other methods. There are lots of different methods for multiplying. This just happens to be the one that scales pretty easily, and this is the one that I was taught. So this is the one that I tend to use. So I'm going to choose which of these to break up. I choose to break up the first one. What does that mean? Well, let me write it out. X plus 1 times x minus 2. Okay. What I'm going to do is I'm going to break up the x plus 1. First the x, and then the plus 1. So I've split it up. And then I'm going to give an x minus 2 to both of these. So in other words, we're kind of taking turns. If I want to multiply x minus 2 times this whole thing, it's really hard to do just all at once. Our brains just don't, well, I will not say everybody's. My brain can't do that all at once. So I got to split it up into steps. And so I choose to break it into the x times the x minus 2 and the 1 times the x minus 2. So then I follow exactly the same method I used right up above, because now this is a monomial times a binomial. So it's just like what we did up here. I'm going to use the distributive property, and it's going to let me multiply x times x. And then I've got a minus there, so I'm going to say minus x times 2. I've got a plus there, plus 1 times x. And then a plus times a minus is a minus. So minus 1 times 2. So let's take a look at the beginning, and let's look at where we got to. So basically, x and 1 are together. X and 2 negative 2 are together over here. And what are we doing? We're trying to take everybody from here and mix them with everybody from there. So this x gets to be with the x and the minus 2 right there. And this 1 gets to be with the x and the minus 2. So basically, we're trying to make a mix where everyone gets to multiply times each other. Now, does x ever multiply times 1? Well, not this x. And does this x ever get to multiply times negative 2? No, they started out together. So this x mixes up with these two, and this 1 mixes up with these two. Okay, so then I end up with x squared minus 2x plus x. Remember, if we've got 1 times a variable, you can just write the variable, minus 2. And then a lot of times, these two terms in the middle will simplify. They will combine. So we can actually take them and go and make them smaller. By which I mean I can combine them and make it negative 2x plus 1x is negative 1x. And that's my final answer. Woohoo! This is very exciting. Yay! Okay, so let's go on to the next page and let's see what we can see there. I'm sure there's more fun, isn't there? Yes, Godzilla's very excited. Godzilla is so excited. And then afterwards, if it goes really well, maybe we could go eat a whole country or something, stomp on some buildings. Super fun stuff. Okay, number 2. Dun, dun, dun. These are still binomials, but I've just made them slightly more complicated looking. So I've got y cubed minus 5, that quantity times the quantity 2y squared plus 4. And again, I didn't say it on the first page, so I do want to mention, just in case you're curious, whenever two things are written right next to each other like this, there is something called implicit multiplication. And that just means whenever two things are written next to each other, multiply them. That's the shorthand. So that we don't have to write multiplication all the time, which we would be writing little dots everywhere. And it would look like polka dots everywhere. So, and then what we're going to do with that, let me give myself some more space. I'm going to rewrite it. You do not have to write it as many times as I'm writing it. I want to mix each of, oh my goodness, this is very complicated. I want to mix the y cubed times each of these and the negative 5 times each of these. And that's, again, like I said on the first page, that's more than my little brain can handle. So what I'm going to do instead is I'm going to break up this first binomial and I'll multiply y cubed times this whole second one. 2y squared plus 4. And then I'm going to break down the minus 5 times the 2y squared plus 4. Having done that, then I can, and you know what, if you ever run out of room, you can always draw the arrows underneath. The y cubed goes and multiplies times each of those terms, and the minus 5 goes and multiplies times each of those terms. So rather than having a billion little arrows running around, or 4, it seems like a billion to me, you just break it down so we've got 2 multiplications here and 2 multiplications here. So we take them one at a time. And it's really great that we can do this. It makes it a lot simpler. I've multiplied the y cubed times each of these. And then I'm going to multiply the negative 5. Now, negative 5 times positive 4. That's still going to leave me with that minus. And I'll remind you that generally speaking, we do not have to write the multiplication in as long as we're dealing with variables. When we get two numbers or constants together, we do have to multiply. We have to write in that multiplication. Otherwise, it'll look like 52 or 54. Okay, I'm going to simplify this one in my head. Don't worry about what's coming. Don't worry about that. Don't worry. That will sort itself out when we get there. I've got, I think, 2y to the 5th. And then 4y cubed. This one's going to be negative 10y squared minus 20. And in this case, nothing combines. There's no way to simplify it, so this is it. This will generally turn out nicely like this, as long as your individual factors, each of the things inside the parentheses, your binomials, are written in descending order. See how it's y cubed first and then the negative 5, and this is 2y squared and then the 4. So that's what puts these in the right order. If you multiply two binomials or, larger polynomials, longer polynomials, and they're in kind of a, just our ramshackle order, just whatever order, random order they came in, you may need to move terms around to get them in descending order. This is, again, y to the 5th, y cubed, y squared. So the exponents are going down as we go along, left to right. Okay, so you guys ready? Dun dun dun! You ready to graduate? Yay! Let's do longer polynomials! Yay! I know everyone's very excited about this. Godzilla's very excited. Get these done and go step on some cities, smash some buildings, eat some cars. Very exciting. Yes, okay. So, with longer polynomials, you can still use most of the methods you've probably been using. So this method where we break it down will still work. The lattice or chart method will also work. So you can use a lot of different methods. The goal with any of these methods, if you're going to be going on, especially if you're going to go on to calculus, is that when you start, be really careful, write out all the steps. But definitely keep working on building up that the skills in your head to be able to do more of it. Push yourself to see, can you do it in your head? And then check it on the paper. Practicing and building these skills are really going to help you. So as I'm looking at this, I'm thinking ahead. I'm thinking, okay, I have to multiply everybody in the first, the P times everybody here, and then the 2 times everybody there. So first step I usually do is I'm going to write the problem again, slightly bigger, just to make sure I know what's happening. This is kind of like the step if you've ever done a recipe where you read it through once, just to make sure you're not going to be surprised that suddenly you need, I don't know, horseradish, and you don't have any horseradish. So you'll know, okay, this is, I've looked through it all. I think I know what's involved. I'm multiplying a binomial, and this one's called a trinomial, binomial times a trinomial. A little note, you could be thinking to yourself, 2 terms multiplied by 3 terms is going to be 2 times 3, which is 6 terms. So I'm going to end up with 6 terms before I simplify. So that's something to think about in the back of your head, just to keep track in terms of the accounting. And I'm going to use this split up method. So I'm going to split up the P and the 2, give myself a lot of space, and then I'm going to multiply the P times the whole second one. So here's the second factor, P to the 4th minus 2P cubed plus 3. That's this guy right there. I've got a plus in the middle. Where did that plus come from? It's a good question. Where did that plus come from? It came from right there. So I'm splitting up the P plus the 2. Right there, P plus 2. Okay, so plus 2, and then I've got that whole second, I haven't touched that trinomial, the second polynomial, the second expression. I haven't touched it at all. It's just staying, it's waiting, and we're going to visit. The P is going to go visiting, and then the 2 is going to go visiting. Okay, so then I've got, and again, go ahead and, write as many steps as you need to feel confident to not make mistakes, but also be thinking in the back of your head, push yourself to do more of this in your head. Like if you can think P times P to the 4th, that's P to the 5th. Nice work. But I'm going to write it out. P times P to the 4th. I'm going to anticipate the sign. There's a minus. And then it's P times 2P cubed. And then P times plus P times 3. That's all from this one, right? P, 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 like that. And then I'm going to take the 2 through. plus 2 times p to the fourth. Positive times a negative will be negative 2 times 2p cubed. And then a 2 times 3 plus 2 times 3. Okay, altogether, 5p's, p to the fifth, minus, bring the constant to the front, 2, and then p times p cubed means we got 4 of them altogether. I've got plus 3p. Now here I've got plus 2p to the fourth, minus, looks like 4p cubed plus 6. Now, in this particular case, come on down here. In this particular case, I am going to have to move terms around because this is descending and this is descending, but there's some overlap, right? I've got the p to the fourths, I've got some p's running around, and I need some colors. Let me find some interesting colors. So let us identify an interesting thing that's happening. This minus 2p to the fourth and this plus 2p to the fourth are going to cancel out, so we're not going to see them. I've got a p to the fifth. These two cancel out, so we won't see them in the final result. And then I've got the 3p, but I'm going to write down the 4p minus 4p cubed. And then this gets very complicated. When I start writing things down, how do you keep track? Well, the way I used to do it when I was in school was I would make a little mark underneath when I had copied that down. I put a little dot underneath. Some people like to scratch it out. That's fine. Make sure that I, the instructor, or whoever your instructor is, can still read it. If you scratch it out so that the person can't see it and you make a mistake, then the instructor who's grading it can't see what you had before. So it'll be harder to know what might have gone wrong. If we're going to help you, if we're going to say, okay, let's take a look at this, see what happened. So it's a good idea to do something that will mark them as used. I wrote this down here, that will not interfere with reading the previous problem. And in fact, if you're reading the previous step, just to check your work, you don't want it all scratched out. That makes it hard. Okay, let's see. I got these two because they cancel right there. And then I've got the 3p. And then I've got the plus 6. I got them all. I've got everybody. Yay! And again, if this order isn't quite right, you can always keep moving them around. It doesn't have to be your final answer. Now, I want to look back up here. It said we should have 6 terms, and 1, 2, 3, 4. There are only 4 terms, so seriously, what's wrong? Bad advertising, right? Well, the 6 terms happen before simplifying. So this is before combining. So if I look up here, 1, 2, 3, 4, 5, 6. There are my 6 terms right there to double check if you're just curious. And then there we go. There's our final answer. Woohoo! Now I'm going to peek over to see what the next problem is because the video is getting kind of long. I'm going to do it. But I'm going to remind you, you have now been staring at the video for almost 25 minutes. So it is a good time to pause the video, go take a break, get something to drink, look at something green, change your where you're focusing. One of the best ways to let your eyes rest is look away from your computer screen or your smart device and look at something that's far away. Look at something that's across the room. Let your eyes relax that way and then come back. You can always pause the video and come back. Okay, welcome back. Yay. Okay, here we go. Dun, dun, dun. This problem is going to be the last one we do in this video. This is a complicated problem. So take a deep breath. We're going to do it. I have 1, 2, 3, 3 terms. This is a trinomial times another trinomial. Woohoo! This is a lot. And like we did before, 3 terms times 3 terms is going to give us 9 terms. which is a lot of terms to keep track of. So you want to give yourself lots of space. This is not a time to save paper. This is a great time to use a smart device so you're not using any paper, or use recycled paper if you can. The paper I use is recycled content. Use scratch paper, use the backs of the paper, but give yourself space. This is not the moment to save the world. This is the moment to take some space. Also save the world, but give your brain the space it needs. Don't squinch it up into a little tiny space. Okay, so to that end, I'm going to write this out nice and big. The particular type of, learning difference I have is that my brain tends to see things and then think they look like other things. So the bigger I write, the better my brain does with not doing that. Or when I do it, the easier it is for me to see, I changed that number to a different number. Okay, so first thing I'm going to do is decide which one I'm going to break up. I'm always going to break up the first one. You don't have to. You can break up the second one if you want. You get to choose. It'll work both ways. That's the great thing. You can also use the lattice or chart method or another method. So I'm going to take this and I'm going to make it 5x cubed. And then, again, green for Godzilla. Godzilla loves the green. This second factor, the second polynomial, I'm going to write in its entirety for each of these terms. So I've got this guy right there. And you can see, now, it could be, and I don't do this, why don't I do it? That is a good question. I need to rethink this. Maybe I will do this in the future. I've had a lot of students point out that this is a lot easier, long ones like this, if you turn the paper sideways. Then you've got a lot more space. I should be listening more to my students, eh? Because that would be brilliant. But the die is cast, sadly. So I'll be just trying to squish it in here. Let's see if I can do it. I'll try to change the way I'm writing things. And again, what are the signs? The signs are dictated by whatever sign comes ahead. So if it's plus x, this is plus x. Minus 4, minus 4. Looks like that. Okay. So now that I've split it up, I've got the second one given out. Each of these terms gets its own second polynomial. Exactly the same. And let's go ahead and multiply out. So I've got 5x cubed times negative 2x squared plus 5x cubed times 3x plus 5x cubed times 6. Ooh, I am going to run out of room, huh? Plus x times negative 2x squared plus, x times 3x plus x times 6. Notice I'm not doing anything fancy with the signs yet. This one is a little too complicated. I do not trust my brain to do it. Again, you can show as much or as little work as you like. Make sure when you do problems like this, though, you leave enough breadcrumbs so whoever is looking at it, either to grade it or to help you, or just to look you looking over it, leave yourself enough breadcrumbs so that if you do find a problem, you can go back and see if you can figure out what happened. So make sure you give yourself lots of space for that. And I did not give myself lots of space. So I'm going to write down here. I apologize. Minus 4 times negative 2x squared minus 4 times positive 3x and minus 4 times 6. Okay, so this is the last one. Okay, that's a lot. Shall we go forward? We can do it. Now, right now, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 little chunks. That's what we were expecting there. So that's good. I've at least got enough of them. They might not be the right ones. I may have made mistakes, but we're going to do our best. Okay, now I'm going to start combining. And the way I'm going to do it, let's see, how should I do this? Let's try doing this all at once. So what does that mean? 5x cubed times negative 2x squared. The 5 times the negative 2 gives me negative 10, and I end up with 5x's. So that's that first one. Okay, second term. 5x cubed times 3x. 5 times 3 is 15, positive 15. And I think I have 4 x's. X cubed times x gives me 4 of them. Now here I've got 5x cubed times 6. 5 times 6 is positive 30. X cubed. Okay, those are my first 3. I'm chunking those together to remind you they came from this first piece. Okay, next piece. X times a negative 2x squared, that's going to be a negative 2x cubed. X times 3x is going to be positive 3x squared because there are 2 x's. And then x times 6 is just plus 6x. And I'll remind you that our convention, the way that we generally sort these things out, as was decided a long time ago, is the number part, the constant, goes at the front. So it's at the beginning. And then in the last step, I've got some interesting things happening. Negative 4 times negative 2. Again, 2 minuses multiplied together. 2 minuses make a plus. Woohoo! So this is going to be a negative times a negative gives me a positive 8x squared. Negative 4 times 3x is going to be a negative 12x. And negative 4 times 6 is a negative 24. There's that third chunk. Okay, so at any point in this video, if you're like, wait, what? Where did that come from? Stop, pause it. You can always take a screenshot. If you're in my class, you've got a copy of the notes and take it, email me, message me, talk to me in class, talk to the tutors, say, I don't know where the 6 came from. And we can go back, So far so good. If you break this down a different way, you will get all these same terms, probably, but you will end up with possibly a different order. So keep that in mind. Okay. Now, how am I going to do this? Well, the way that I generally approach these at this point is much like Godzilla. If Godzilla's trying to eat a city, you can't just eat the whole city in one go. So you've got to choose, how you're going to approach it. So I usually start with the highest exponent, the greatest power, and I write those down. Negative 10 x to the 5th. And then, of course, the way I mark it is with that little dot. If you would like a single slash, again, don't demolish it. I know, Godzilla's like, demolish it. Godzilla, there's no way. If you demolish it, there's no way to go back and check your work. Okay, so just a little tiny mark. Do I have any x to the 4ths? And the answer is yes, I do. I have the plus 15x to the 4th. Do I have any x cubes? Yes, I've got a couple of them. They happen to be right next to each other, which is really convenient. And then my x squareds, yep, I've got a 3x squared right here, and then I've got another 8x squared right there. Do I have any x's? Yep, I have the plus 6x, and the minus 12x, and then the minus 24. And a lot of people are probably asking, wait, why did you do that? That's just a big bunch of work, and I don't need to do it. If you don't need to do it, don't do it. My brain totally needs to do it. Negative 10x to the 5th. I'm going to do plus 15x to the 4th, and now we start combining. There are 2 like terms right there because they both have the same x's, x cubed. 30 minus 2 is 28. If you have $30 and you spent 2, you've got $28 left. 3x squared plus 8x squared. I've got $3 plus $8, or 3 apples plus 8 apples. I get 11 apples, or x squareds. I had $6, but I spent 12. Whoops, I overspent by $6. So 6 minus 12 is negative 6. And then the minus 24 at the end. And we are Done. Woohoo! I didn't give myself enough space. Ugh, can't believe it. I'm always saying give space and then I don't. Congratulations. Woohoo, we did it. You can use the same method as long as the polynomials are. After a while, you may want to use a slightly different method. You may want to switch to the lattice method. If you've got a 10-term polynomial times a 10-term polynomial, you're going to want a lot of paper regardless. But this method scales completely. So you can use any of these methods to do that. You guys are brilliant. I'm sorry, the video is so long, 35 minutes. That's a long time to stare at the TV screen. So definitely pause. Go look at something green, go do something, that makes you happy, reward your brain, maybe a little nap or a snack or some water, pet an animal, go make some music, dance around, all those fun things. And know that you're amazing and incredible, and I believe you can do this. And if you have any questions, please come ask them. And otherwise, just keep being awesome. Woohoo, and math on.